Okay, this is going to be an excellent recap of all your skills. So let's see, there's a light seesaw that is 10 meters long with a pivot 3 meters from the left. So the key point is the pivot. This is the pivot. This is the 10 meter long seesaw. Now 4 kilogram weight is related to this, and it's placed on the left hand side of the end of the seesaw. Write down anti-clockwise moment about the pivot. So if this is hands on the clock from the pivot, that distance is 3. Now you just need to remember that moment equals force times distance. Now the force, because this is a weight, we have to do 4g to get the force. So in this sense it's because we have F equals ma and A is the gravity, which is 9.8. So this is the force. So the force here is going to be 4 times 9.8. Just to break this down for you. So that becomes newtons, 39.2 newtons. We should be good up to there. So if moment equals force times distance, we have a distance here of 3 meters. So we just need to do 3 times 39.2, which equals 117.6 newtons. That part is done. Now B, a force of magnitude Fn, which is here, is applied to the right hand end of the seesaw. The force acts vertically downwards. Now if this is the pivot, imagine this as a clock hand, that weight will pull it down. So that is going clockwise, that's a clockwise moment. Due to this weight, because it's weight, due to weight, but they've given you the force in newtons, so we do not need to times it by 9.8, because look at this, force equals mass times acceleration. So for part B, the moment literally equals the distance. So what's this distance? It's going to be 7, because it's 10, this 10 here, minus this length 3 right here. So it's just going to be 7 times F, which equals 7F. That's your 1 mark, done. Part C, so find the value of F for which the system is in equilibrium. So that means the anti-clockwise movement is going to equal the clockwise when in equilibrium. Clockwise equals the anti. So all we need is to set an equation up. We've got the left hand side, anti-clockwise, is going to equal, from what we worked out in part A, 117.6 is going to equal 7F. So we just divide out by 7. So F is going to equal 16.8 newtons. That's a very easy 7 marks, and that's going to recap all your skills. Okay, so pause this video at any point. We're now doing this question 2. Alice weighs 50 kilograms. The other read of the question. Draw a diagram showing the forces acting on the seesaw due to the 2 people. Label the value of each force in newtons. Now Bob, he weighs 80 kg, so just write 80g, that's the gravity on him. Alice is 50g, and that is all you need to do for your 2 marks. So that's part A done. Now let's have a look at part B. Write down the total clockwise moment about the centre in terms of x. So clockwise from the pivot here, this is going to be Alice. So let's just write Alice's moment. So what is that going to equal? The whole length is 4 meters, so from here to Alice must be 2 meters. So essentially that's all it is 2 times 50g equals 100g. Now it does say the total clockwise moment. So Alice is clockwise. Now Bob, the moment that Bob causes, you can see it's anti-clockwise. So Bob is from here to here. When you can see that is 2, that must be 2 minus x. So that must be 2 minus x times 80g, and that is perfectly fine for that. So the total clockwise moment, if we expand out Bob, Bob is going to be 160g minus 80xg. So let's do clockwise and anti-clockwise. Well, Alice is the clockwise, so that means we have to have 100g minus, so it's Alice minus Bob. So Alice is 100g minus Bob's 160g. Now that's in a bracket, it's minus 80xg. So let's put the g in. So you get minus 60g plus 80xg. Because you can see Bob moment is greater. So the clockwise moment, it has to be negative, that makes sense. So let's just factorise that out. That's going to be 20g. We have the 4x here and minus 3 Newton meters. That's the total clockwise moment. Let's do C. Find a value for x for which the seesaw is in equilibrium. So that means both sides are equal. So 100g equals 160g minus 80xg. Right here we've got g in every term, so we can just divide out by g to be left with 100 equals 160 minus 80x. I'm going to minus 160, so minus 60 equals minus 80x. Divide by minus 80 on both sides. So you get 6 over 8 equals x, which is the same as 3 over 4, which is, in the context of this question, is 0.75 meters. That's part C done, a nice easy 2 marks. So let's do part D here. Given that Bob remains on the opposite side to Alice, describe with inequality the range of x for which the seesaw tilts towards Alice. So this is just a thinking skill. So when in equilibrium, that's 0.75 meters. Now x is going this way. That's in equilibrium. So if Bob shifts this way, you know from the start, from part B, this was the clockwise moment. It was leaning, it was going to tilt towards Bob. Okay. So that's 0.75. If Bob continues moving this way, it should become self-evident that the seesaw will tilt towards Alice because the moment here is greater. So D has to be between 0.75 and x and less than or equal to 2 meters, because 2 will be the limit, otherwise it will be going past the pivot. E. What is one limitation of the model? You just need to write any valid one. The pivot is not a point. Seesaw could bend. In real life it will not be 100% rigid. Alice can't really sit right on the end. Right, which I mean exactly on the end. And that's it. So this breaks down all your skills to interpret and answer more challenging questions. Okay, so let's look at this question. A 5,000 kilogram bus hangs 12 meters over the edge. That's a 12 meters here. That's the cliff edge. It has 1,000 kg of gold. The gold sits on a wheel cart. A group of M people, each weighing 70 kg, stands at the other end. The bus is 20 meters long, which is highlighted here. Now, please feel free to pause the video at any time. Write down the total clockwise moment about the cliff edge in terms of n. So when we're doing that, we've got to consider the clockwise and the anti-clockwise and combine them together at the end, which I'll show you. So the gold is 1,000 kg, so the kg is a clue. So you write 1,000 g here, let's label that. That's 70 gn or 70 ng, because n is the amount of people. Now the bus weighs 500 kilograms, so we take that from the centre of mass. That's 12. So at about 10 meters in, we're going to have 5,000 g, because that's 10 there. That's 10 meters right here. Okay, so let's just do the clockwise moments. So moment bus. Let's just break this up bit by bit. Good to write this out in the exam, just so you definitely earn your method mark. So this point here is the pivot. So from here to here is 2 meters. So we get 2 times 5,000 g, which equals 10,000 g. This will help us work things out later. The gold is going to act clockwise as well. So we've got the moment from the gold. We know that's 12 meters, so that's 12 times 1,000 g equals 12,000 g. And actually that's a method 1 answer mark here, method and answer mark here. That's a method mark, not to do with the question. Now let's do the moment from the people. That's the pivot. The people is going to make that anti-clockwise. So that's anti-clockwise. Moment from the people. So if that's 12. That's going to be 8. So we get 70 g n times 8, which is going to be 560. Should do it in leave gravity at the end, so I'm just going to write 500 ng or 560 gn, the same thing. Right, that will get you a method mark and answer there. So if you think about it, the total moment. So the total moment is going to be adding these clockwise moments here, minus the anti-clockwise moment, the moment of the people, because this will make sense. This is pulling this, keeping this bus on the cliff edge. The gold and the centre of mass of this bus is going to make it tilt over. So the total moment is going to be the bus, 10,000 g, and we're doing it all clockwise, going in a clockwise direction, plus the 12,000 g, that's the moment of the gold, minus the moment of the people. And I was going to write moment of people there, but that's 560 ng. Right. So that's going to make 22,000 g minus 560 ng, and then we can just factorise the g out for cleanness. minus 560 n and g on the outside. That's part A. That is 7 out of 7. You can see that's quite easily done. Now let's look at 3b. Find the smallest number of people needed to stop the bus falling over the cliff. Well, as you can see, depending on the value of n, at the moment it looks like the bus is going to tilt over, as in that bus is going to fall down the cliff, because that, unless this side here is greater than 22,000, the bus is going to topple over. Because for the bus not to topple over, we want this moment anti-clockwise to be greater. Right, so we need to form an inequality. So if we start off with 22,000 needs to be less than 560n, divide by 560 on both sides, divide by 560, divide by 560, we get 39.29 to 2 decimal places. It's an n. So if you write it the other way around, n has got to be greater than 39.29 people. So you're going to be n needs to be 40, right? So the anti-clockwise moment is more, and the bus stays on the cliff. So need 40 people. That's B done. Now we have C. One person needs to walk to the end of the bus to retrieve the gold. Because these people are greedy, so let's draw the person here. They want to keep the gold and save their lives at the same time. So let's look at C. So what does that change this thing to? You need to, this person is 70G. So this bit here actually becomes 1070G. So we still have the same moment from the bus, the gold. So moment gold is going to equal really the 1000, add the 70 people, all times G, and times the distance, which is 12, so that's going to be 1070G times 12. Now that's the clockwise. The bus moment is the same for the centre of mass. Moment just from the bus COM, centre of mass, is going to be the same as before, 10,000 G. Now what does, just checking what that equals, 12 times, that's 12,840 G, and the moment from the people is going to be the same because we don't know the amount of people. So just remember the moment, the people, which is anti-clockwise, is going to be 560 ng, because we don't know what the amount of people in the bus. Find the smallest number of people needed to stop the bus falling over the cliff in this situation, including the one retrieving the gold. So new total moment is going to be add the two clockwise moments together, G minus 560 ng. Right, so if we could actually leave that like that, or we could factorise the G out. That's the new total moment. So we still need to create the inequality from before. We want that to be in equilibrium because it's not the smallest amount of people, so we're going to get 560n. We can say 560ng equals 22840g. We can cancel out g's, so we get 560n equals 22840. Find out what n equals in this context by dividing by 560, which equals 40.78623 dp. So we really need to round that to 41 people to make the extra amount, and the final answer is going to be 42 people because we need the extra one to collect the gold, so that we could be rich and have our lives saved. So that should make sense. So this means we need 41 people here to keep it stable, but you do need to include the one collecting the gold, so that's 42.